So this is part 1 of the Chapter 8 practice test for geometry. So the first 5 questions, the directions say, simplify the radical by identifying the largest perfect square that divides into the value given. So for number 1, we're going to take the prime factorization of 36, which is 2 times 3 times 2 times 3. We have a pair of 2s, so one of them comes out, and we have a pair of 3s, so one of them comes out. And then when you multiply the 2 times the 3, you get 6. Nothing left inside the radical on that one. Same thing for number 2. You take the prime factorization of 324. You get 2 times 2 times 3 times 3 times 3 times 3. Every set of pairs, you pull 1 out. So 2 times 3 is 6. 6 times 3 is 18. Nothing left inside the radical. Number 3, you're going to do the prime factorization of 96, which is 2 times 2 times 2 times 2 times 2 times 3. One of these 2's comes out. One of these 2's comes out. They multiply to get 4. And then you have a 2 and a 3 left inside. They multiply to get 6. For number 4, you take the prime factorization of 147, which is 3 times 7 times 7. You have a pair of 7's. One comes out in front of the radical. The 3 does not have a pair, so it stays inside the radical. Number 5, you're going to take the prime factorization of 360, which is 2 times 2 times 3 times 3 times 2 times 5. So one of the 2's comes out, one of the 3 comes out. That gets you the 6. The 2 and the 5 don't have pairs, so they multiply and get the 10 inside the radical. For numbers 6 and 7, the directions say use the Pythagorean Theorem to find the missing side of each triangle. Round your answer to the nearest tenth if necessary. So the Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are your legs, and c is always your hypotenuse. So on this particular triangle, 6 and 8 are your legs, x is your hypotenuse. So you plug in your 2 values for your legs, and for the hypotenuse, you plug in x. 6 squared is 36, 8 squared is 64, add them together, take the square root, and it comes out perfectly. No decimal needed. For number 7, one of the legs is 3, and one of the legs is x, the hypotenuse is 5. So you plug in your 2 legs, you plug in your hypotenuse, and you simplify. 3 squared is 9, 5 squared is 25, so you subtract the 9, then take the square root of 16, so you should have 4 centimeters. Numbers 8 through 10, the directions down at the bottom say use the Pythagorean Theorem to find the missing side of each triangle. Leave your answer in simplest radical form. So this time, instead of giving a decimal, which we technically didn't even get a decimal, but if you did, you would have put it there, you're going to leave your answers as radicals. So for number 8, these are your 2 legs. Here's your hypotenuse. So plug it into the quadratic, or the Pythagorean Theorem. 9 squared is 81. And then the square root of 145 squared is 145. Subtract the 81 from both sides, which leaves you with 64. And then when you take the square root, you get 8. For number 9, these 2 are your legs. That's your hypotenuse. So plug in the 9 and the 11. 9 squared is 81. 11 squared is 121. Add them together. Or no, subtract the 81. You get 40. Take the square root, and you'd get a decimal, but they don't want the answer in decimal, they want it as simplified radical. So you have to get the prime factorization of 40, which is 2 times 2 times 2 times 5. So one of the 2's comes out in front, and then 2 times 5, oh, that should be 10 in there. Should be 10. All right, number 10. Here's your 2 legs, that's your hypotenuse. So you're going to have square root of 5 squared plus the square root of 5 squared equals x squared. So the square root of 5 squared is 5. Same thing here, add them together, take the square root. And then turn over to page 2. Directions at the top of page 2 say find the missing length by separating the triangles, writing a proportion, and cross multiply. Leave your answers in simplest radical form. So for number 11, you're going to use that altitude squared, set it equal to the 2 smaller pieces here, multiplied together. So I calculated this piece by subtracting the 64 from 100. You multiply the 64 times 100, and then you take the square root. I got 48 exactly. So I didn't need to do the prime factorization. Same thing with number 12. The altitude squared is equal to this piece times this piece. So 16 times 9 is 144, and the square root is 12. Number 13, instead of having the value of the altitude, now you have one of the legs. So you're going to say that leg squared is equal to the piece closest to it times the length of the whole thing. You just multiply them on your calculator and take the square root. If you get a whole number, great. If not, you're going to have to do the prime factorization. Another leg, so you say the leg squared equals the piece closest to it times the length of the whole thing. Multiply them together, take the square root. And then number 15, this one's back to the altitude. So that altitude squared is going to be equal to this times this. Well, to get the length of this one right here, I had to take the length of the whole thing and subtract the piece I knew, which means I'm going to end up using the distributive property right here. So I multiplied 64 times x and 64 times negative 64, added the 4,096 to both sides, divided by 64, so I got x is equal to 100. Down at the bottom, numbers 16 through 20, the directions say find the missing side lengths by writing proportions and cross multiplying. Leave your answers as radicals in simplest radical form. So I found the angle 60 degrees, and I labeled the sides what they were from that angle: opposite, adjacent, and hypotenuse. I wanted to solve for m first, and the side I knew was the opposite, so that's the sine function. So I said the sine of 60 is equal to the opposite over the hypotenuse, created a proportion by putting a 1 in the denominator, and then multiplied cross product. Okay? Once you multiply cross product, you want to get the m by itself, so you divide both sides by the sine of 60. Those cancel, and you should get m equals 18. Then I needed to solve for n. So n was the adjacent side, so I need to use adjacent and opposite, which is tangent. So the tangent of 60 is equal to the opposite over the adjacent. Do the cross product. Well, make it into a proportion by putting 1 in the denominator. Do the cross product. Divide both sides by the tangent of 60. I got n equals 9. Number 17. From this angle, I labeled the sides opposite, adjacent, and hypotenuse and solved for x first. So I decided to use sine because I knew I wanted to find out the opposite and get the and knew the hypotenuse. So the sine of the angle equals the opposite over the hypotenuse. Make it into a proportion by adding 1, do the cross product, and I got the decimal, which it wants your answers as a simplified radical. So when you're taking the test, if you look at all your answers and they're as simplified radicals, simply type them into your calculator and write down what they are as radicals or as decimals and see which one comes out to 15.9. That's your answer. Same thing. Oh, no, we'll see that one again. All right, now let's solve for y. So we know we want the adjacent and we know the hypotenuse. So that would be cosine. So we did the cosine of 60 equals the adjacent over the hypotenuse. Do the cross product after you make it into a proportion. And this one you just multiply. I got 9. Jumping down to number 20. From this angle, I labeled all 3 sides. Decided to use the cosine first to solve for m. Set up the proportion using cosine. So cosine is adjacent over hypotenuse, and then did the cross product and solved for m. Then I needed to solve for n. So n is the opposite. So I used opposite and adjacent, which is tangent. So the tangent of 45 is equal to the opposite over the adjacent. Make it into a proportion, do the cross product. Again, I got a decimal. So I looked at all the answer choices, change them to a decimal, and see which one is equal to 4.24. My writing's so huge, I had to do 18 and 19 on another paper. All right, so number 18. First I solved for x. So from that angle, I used opposite and hypotenuse, so I chose sine. Set up my proportion, did the cross product. These cancel. I got the decimal 6.93, so look at your radical choices. Type them into your calculator and see which one gets you the same decimal. Now then I need to solve for y. So I use tangent, which is opposite over adjacent. Created my proportion, did the cross product, divided by the tangent of 60, got a decimal. So checked my answers to see which one it was. Number 19. To solve for m first, I use the cosine, which is adjacent over hypotenuse. And then set up my proportion, did the cross product, divided by the cosine of 45, got a decimal. So checked my radical answers. Obviously not going to be 4 or 8, but when you see it on the test, it might be like that. And decided which one was the same as that decimal. Then for n, I use tangent of 45, so it should be opposite over adjacent. Create a proportion out of it, do the cross product. I got 4.